Okay, so we're going to do one problem at a time on the buffer worksheet, lesson 22. So what I would do is practice the problem first, try to set it up, and then watch the video. Then do the second one, the third one, and there should be a total of 7 buffer problems. So there should be 7 separate videos for lesson 22. And then there'll be the ones for the titration worksheet, which is lesson 23. Okay. Here we go. So it says to calculate the pH of a buffer. So the first thing I'm going to think of is Henderson-Hasselbalch. And we are told that we have a 0.3 molar solution of hydrofluoric acid and a 0.7 molar solution of NaF. So this is my weak acid. This is my conjugate base salt. Okay. And I have a Ka value of this. So hydrofluoric acid in water makes fluoride and H3O plus, and we know that because it's a buffer problem, we don't necessarily need an ice table, but if you were unsure, you could set one up and solve it that way. Starting with 0.3 molar of hydrofluoric acid, all of my fluoride is going to come from my sodium fluoride, which is initially present, and I have none of this. This is really what my unknown is, and so I'm going to use these values to plug in to my Henderson-Hasselbalch, which is the pH is equal to the pKa plus the log of AH, where fluoride is my A minus, hydrofluoric is my HA, and I have my Ka value. Remember, in these problems, the reason why we don't have to use the ice table is because the minus x and the plus x are going to be negligible, so we get to assume that they go away. Okay, thank you. Not right now. I'm recording this video. Come in just a minute. There's a bird outside and my kid wants me to come look at it. Sorry, so I took the negative log of the Ka value and I don't know if that's right, 0.7 divided by 0.3. Fuck. There we go. Okay. So this would be the pH if I solved it with the Henderson-Hasselbalch, and but if I was unsure and I wanted to know if I could use the Ka, remember initially I said I don't know what my hydronium concentration is, and so I could do just a traditional equilibrium expression. I have too many parentheses. Sorry guys, that was bothering me. So at equilibrium, because I'm in a buffer, my I values and my E values are the same. I still don't know this value. And so I could technically plug in the values I have at equilibrium. And when I solve for x, I get 0.000304 molar, which is the concentration of hydronium, and I can plug that into the pH as the negative log of, and I get a pH of 3.52. So the nice thing about these problems, you can use an ice table or you can use the Henderson-Hasselbalch, but regardless you get the same answer.